Space often looks calm from a distance. From Earth, the night sky appears silent and peaceful, scattered with small points of light across a deep black sky. But the truth is far more unsettling. Our solar system is not a quiet place. It is violent, unstable, and filled with forces so extreme they could destroy worlds. Temperatures hot enough to melt metal. Radiation powerful enough to kill in seconds. Storms that could swallow entire planets. And these dangers are not hidden in distant galaxies. They exist right here, orbiting the same star as Earth. To understand how hostile our cosmic neighborhood really is, we have to begin with the most powerful object in the entire solar system: the Sun. At first glance, the Sun seems gentle. It warms our planet, drives our weather, and provides the energy that allows life to exist. Every sunrise feels calm and predictable. But the Sun is anything but calm. Deep within its core, unimaginable pressure forces hydrogen atoms to fuse together, creating helium and releasing enormous amounts of energy. This nuclear fusion powers the star, sending heat and radiation outward into space. The scale of this energy is difficult to imagine. In a single second, the Sun produces more energy than humanity has used throughout its entire history. And sometimes that energy erupts violently. Across the Sun's surface, twisted magnetic fields snap and reconnect, releasing enormous bursts of energy, known as solar flares. A solar flare is one of the most powerful explosions in the solar system. In just a few minutes, it can release energy equal to billions of nuclear bombs. Sometimes these eruptions launch something even more dangerous: a coronal mass ejection. During these events, billions of tons of superheated plasma are thrown into space at millions of kilometers per hour. If Earth happens to be in the path of this eruption, the consequences can be serious. Satellites can fail. Communication systems can collapse. Power grids on the ground can overload and shut down. In 1859, an event like this struck Earth. It became known as the Carrington event. Telegraph systems around the world began sparking and catching fire. Electrical currents surged through wires even after power had been disconnected. If a similar storm happened today, the effects could be far worse. Modern civilization depends heavily on satellites, electricity, and global communication. Yet despite its power, the Sun is only one danger in our solar system. Far beyond the orbit of Mars lies a planet so massive that its gravity shapes the entire structure of our planetary system: Jupiter. Jupiter is the largest planet orbiting the Sun. It is more massive than all the other planets combined. Its enormous gravity pulls comets, asteroids, and debris towards it, acting like a giant cosmic vacuum. In some ways, this protects the inner planets from potential impacts. But Jupiter itself is an extremely dangerous place. Surrounding the planet are enormous belts of high-energy radiation trapped within its powerful magnetic field. These radiation belts are far stronger than those surrounding Earth. A human exposed to this environment would receive a lethal dose of radiation within minutes. Even robotic spacecraft must be carefully shielded to survive the intense bombardment of particles swirling around the planet. Jupiter's influence also creates one of the most violent worlds in the entire solar system. One of its moons, known as Io. Io is the most volcanically active world ever discovered. As it orbits Jupiter, the planet's immense gravity constantly stretches and squeezes the moon. This tidal force generates enormous internal heat. The result is a world covered in volcanoes, hundreds of them. Some eruptions blast molten rock hundreds of kilometers above the surface, while vast rivers of lava spread across the landscape. Io is a world where the ground itself never truly rests. And yet, even this violent moon is only one example of how dangerous our solar system can be. There are planets where the surface itself is hostile to life, where heat, pressure, and atmosphere combine to create an environment unlike anything on Earth. One of the most extreme worlds in our solar system is a planet that, from a distance, looks strangely familiar. Venus. In size and structure, Venus is often called Earth's twin. It is only slightly smaller than our planet and formed from many of the same materials during the early days of the solar system. For a long time, scientists even wondered if Venus might once have had oceans. But the reality of Venus is far more hostile. The planet is completely covered by a thick atmosphere made mostly of carbon dioxide. High above the surface, dense clouds of sulfuric acid circle the planet, reflecting sunlight and hiding what lies beneath. These clouds trap heat with extraordinary efficiency, creating what scientists call a runaway greenhouse effect. The result is one of the hottest environments anywhere in the solar system. Surface temperatures on Venus reach around 460 degrees Celsius, hot enough to melt lead. Even the nights on Venus are almost as hot as the days, because the dense atmosphere holds on to heat so effectively. But temperature is only part of the problem. The pressure on the surface of Venus is crushing. Standing there would feel like being nearly 1 kilometer underwater on Earth. The atmosphere presses down with such force that most spacecraft sent to the planet have survived for less than an hour before failing. Robotic probes that successfully reached the surface transmitted only a few images before the intense heat and pressure destroyed their electronics. It is a world where survival, even for machines, is incredibly difficult. Yet despite the dangers on Venus, some of the most unpredictable threats in the solar system do not come from planets at all. They come from objects much smaller, asteroids. These rocky fragments are leftovers from the early formation of the solar system, billions of years ago. Most remain within the asteroid belt between Mars and Jupiter, orbiting the Sun in a vast ring of debris. But not all of them stay there. Some asteroids are slowly nudged from their original paths by gravitational interactions with planets. Over time, these disturbances can send them drifting into new orbits that cross the path of Earth. These are known as near-Earth objects. Many are small and burn up harmlessly in the atmosphere, but others are large enough to cause devastating impacts. Around 66 million years ago, a massive asteroid struck Earth near what is now the Yucatan Peninsula in Mexico. The impact released an extraordinary amount of energy, instantly vaporizing rock and launching enormous quantities of debris high into the atmosphere. Wildfires spread across continents. Shockwaves shook the planet. Dust and particles filled the sky, blocking sunlight and causing global temperatures to fall. This catastrophic event is believed to have triggered the extinction of the dinosaurs, reshaping life on Earth forever. Today, scientists monitor thousands of asteroids that travel through our region of space. Telescopes around the world constantly scan the sky, searching for new objects and calculating their paths with increasing precision. So far, no known asteroid large enough to threaten civilization is on a collision course with Earth. But the history of our planet reminds us that the solar system is not a completely predictable place. From violent stars to crushing atmospheres, from lethal radiation to wandering asteroids, our cosmic neighborhood is filled with powerful forces capable of reshaping worlds. And yet, despite these dangers, Earth remains a small and remarkably fortunate island of stability in an otherwise hostile environment.